That just seeing Louisa reminded me to remind you all, I've extended the WebWorks. So the WebWorks
Thank you.
have been extended, they're all extended. If you need more time, that's cool too.
When was derivatives 4 supposed to begin?
Gosh, I don't know.
Because I like full transparency, I just didn't get.
No, that's totally cool. And I think now it's due Thursday.
Yeah, it's due the 18th, but I was just curious because it's 3 days, and I was wondering when it was originally supposed to.
Yeah, and we can add more to it.
No,
That's cool.
I was.
And I know you're not asking for that, but I can do that, and I'd be happy to do that. We're in the home stretch. We just got to get through this, Mace.
Agreed.
All of us, and we're gonna do it.
Couple deep breaths.
Yeah, absolutely.
Couple coffees.
So yeah, probably. I'm sure you've had at least a few.
I didn't really have a chance, to be honest. I was trying to get every minute of laying down and resting my legs, to be honest. I got like a half a cup of coffee.
Do you want a fruit roll up?
I'm chilling now because I do plan on getting some lunch and
Okay, all right.
probably getting a full cup of coffee.
There you go. That's fantastic.
Thank you.
Oh yeah, absolutely. I forgot my breakfast and.
That's the breakfast of champions.
Oh yeah, it is. It's better than the Twizzlers. The bag.
That's a winner's. That's a winner's breakfast.
Yeah. All right, friends. So next week I'm going to hand out the final, and it's going to be a take-home thing that we're going to work on in class. So we'll just do a quick review of what's up here. All the WebWorks are extended through Thursday. That can be extended more, as Mace just asked. Derivatives 4, which is probably all chain rules stuff.
I believe it is, yeah.
That sounds completely right. That one is also due on Thursday currently, but we can make that later. Just let me know. You just communicate with me and we'll make it happen. And there is the final web work is up.
The applications one?
Yes, and we were going to talk about that today. I'm going to recommend, and we're going to work on it. We're going to start working on it today. I think there's 8 problems on that. Is it? Yeah. So final web work applications, and it's all business stuff. And hopefully, what I'm hoping is you're going to see a bunch of stuff that you've seen in your other classes, in your business classes, your econ classes, and understand it at a whole new level, because now you know some calculus. So we're kind of done learning the techniques of calculus. We're just going to apply them the last couple weeks here together. So applications, and that is due probably next Thursday, but that could be extended to, hopefully we'll get most of it done today.
It's due the 23rd, actually.
The 23rd, which is, I don't know, that's like next Wednesday. Yeah, we should. I think it'll be fine. I recommend just 1 through 6 until Wednesday, just currently. So I wouldn't start on 7 and 8 at all today. You'll probably be able to knock out 1 through 6 in class, is what I'm thinking. And I think that's about it. Do y'all have any questions on anything? No? Okay. And we'll do work day, so if you have little problems, hey Jack, if you have problems on the existing WebWorks, we can deal with that. So let me get my notes out. But today I wanted to talk about marginal things. How many folks, business people, have you heard the term marginal? Marginal cost, profit, revenue in any of your classes? Awesome. Have you heard about average cost and its relationship to marginal cost? Is this something you've heard anywhere? I barely understand this shit. I mean, like, I am not a business person. I read this stuff. I know the math. Maybe it'll ring some bells when we get to it. So today is all about applications of the tangent. And I want to review that process, and I want to give us a different perspective on it. So today is going to take everything we've learned, and then Wednesday as well, and just start looking at it from a completely different angle in terms of using it. So let's say I've got some function f of x. I've got a graph like this, and I've got the tangent line at a point. So let's say I've got this point A, and I've got the tangent line through there. So real quick, what is the equation of that line? So let's say m is the slope, f of a is the point. Could you just really quickly, just to get your brain started on this, what is the equation of the line y equals, so this tangent line? Just see what you remember. Try to pull it forth and really see what's there. And then we can look at our notes and I'll tell you the answer. Get a little light in here. This is kind of one of those things you probably remember it, or you're going to have to look it up. Can somebody help me with this? What would I write here? Anybody? Mace, you got something for me?
I'm not really too sure, to be honest.
It's okay, you're a sleepy man this morning. I give you all
My
this.
brain's not firing on all cylinders.
It's all good. Lorelai, you got anything for me? Got nothing? That's cool. Caroline, you look okay. Yeah, you were looking down. I should have known better. No eye contact there.
Can you repeat the question?
Yes, yes. If I've got this tangent line to this curve, y equals f of x, through this point with the slope m, what is the equation of the tangent line? Lisa, you got anything on that? Jack, what do you think? It's a good wake-up question. So, what is point slope form? There's not even any calculus here. I've got a point. What's the point we go through? What's the point on the line that I know?
A f of a.
A f of a. So there's the x and y coordinates. Yeah. Slope is m. I'm not going to write that down again because that's just right there. So it is slope times x minus the known x coordinate plus the y coordinate. So this is the equation of a tangent line through a f of a with slope m. How does slope relate to calculus? How does the slope of that tangent line relate to calculus?
Production costs.
Ooh, you're moving ahead. Eventually. We're not in any specific application, just in general. How do I find the slope of the tangent line?
Just the rate of change, rise over run.
It's rise over run. How do I use calculus to do it?
The derivative.
The derivative. Okay. Good. We really need to wake up. This is good. So slope of the tangent equals the derivative at that point. And it's going to turn out it equals marginal things in business. But we're going to try to understand that a lot better. Anytime you see the term marginal, it's talking about a derivative and it's talking about a tangent line. So why do we even care about these tangent lines? Tangent lines are approximations to curvy things. So I'm going to write this out. A tangent line gives us an approximation of behavior near a point. In some ways, and I like to say this in all my classes where we're doing calculus and tangent lines, it's a microscope It's a mathematical microscope. So it's a I'm gonna write that up here and I'm gonna show you what I mean. It's a mathematical microscope. How do I mean that? Well, let's zoom in. Let's say I've got a curve like this and a tangent line. So here's a curve, here's a tangent line. Let me zoom in. So I'm gonna zoom in over and over again. The next zoom in, so I'm gonna blow that whole thing up. And what I've got is something that looks like, here's the tangent line, and then here's the curve. Notice how they're getting closer when I blow that up. You can see they're still separate there. Let's blow up again that point of tangency. So I'm gonna blow that up again. And you can almost not even tell the difference at that point. And let's make it almost not different. And if I blow up one more time, the tangent line and the curve are indistinguishable. So let me put that up. These are zooms, progressive zooms. If we zoom in enough, the tangent line is indistinguishable from the curve. That is in this right here. This is all of it. This is why we care about tangent lines. Because if you've got some wiggly ass thing like this round thing here, you want to pretend it's a line. And if you can just pretend stuff's a line, man, it's so much easier to work with lines. I got this beautiful equation. I multiply and I add, and I've got my answers. With crazy curves, like cost functions, and we're going to take a look at some, we need an eraser. The work can be more challenging. So, let's do a specific example. Let's say I have a cost function. C of x is, and this is a garbage one, it's going to have weird numbers, but let's just say it's 3x squared minus 2x plus 1. Really weird. This is the cost of producing x units of something. Of whatever. Now I could sketch that whole thing out, but I could also take a derivative here. So let's just actually crank out the derivative. Could you do that for me really quick? What is the derivative of c of x?
6x minus 2.
Nice. Do we all agree with that? Power rule? Look good? Cool. Very good. So, this gives me the tangent slope at any point. This is also what's called the marginal cost. And let's talk about what that means. So this curve up here, let's see. Ooh. Let me get a little graph of it. It's a parabola of some kind. I kind of made up the answer. So let's say here's x, here's c. Let's see, when x is 0, cost is 1. I'm going to totally cheese this out. When x is 1, what is my cost? 2. Is that right? When x is 1, I got 3 minus 1 plus 1, that's 2. When x is 2, let's just grab a few points here. What do I get when x is 2? What is c of 2? Can somebody help me out with that? Thank you. Beautiful. Equals 9. So this thing's starting to rocket up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So right at 2, it's 9. And this looks like it's a parabola that's opening up. So probably the vertex is over here. But we got some weird, really steep function. This gives me the slope of the tangent at any point. So let's just look at 1. What is the marginal cost when x equals 1? So to find this, I go to the derivative, and I'm really just finding the tangent slope right here, what is that tangent slope right there? At 1.
4.
4. How'd you get that, Jack?
Plug it in 1.
Plug in 1 to that function, right? So it's 6 times 1 minus 2. That's 4. Thank you, sir. So let's say I wanted to approximate what happens when I'm already producing 1 unit, and I want to estimate what happens if I produce 1 more unit. So marginal stuff means we're essentially not going to go to the curve, which is way up here. So right, here's 1, here's 2. I know the true answer, C of 2 is 9, but I'm going to estimate it. And to estimate it, I just figure out, where is the line? How much change did I see by just pretending the line was my curve? So if this slope is 4 here, how much did this line go up if I go over 1 unit? Yeah, 4. If you got a slope of 4, that means for every 1 unit you go over, you go up 4. So the slope of this line is 4. This means that for every unit increase in x, the tangent line increases by 4 units. So my marginal cost is 4, and that's just really taking the equation of this tangent line and doing it in the simplest way. If I move over 1, I'm not even really thinking about the equation of the line. I'm just thinking about what slope means. So let's take a specific example and take a look at this. And you can see this is a pretty lousy approximation, but mostly because I did a lousy example. So let me actually write this up for you. So the true level of production when x equals 2 is C of 2 is 9. Excuse, true cost, the true cost of production. We estimated that, I gotta kind of put this together here. The marginal cost at x equals 1 unit of production is 4, because that's C prime at 4. So what this means is I'm estimating that my old production, which was, let's see, what was C of 1 before? So C of 1 equaled 4. Actually, this turned out to be not bad. So our original cost level was, wait, did I crank that out wrong?
I was about it.
Thanks.
C prime is 4.
Thank you. C of 1 is 2, right? Yes. So C of 1 is 2. C prime is 4.
I think you meant to put C prime of 1.
Oh, thank you. I did. Thanks, Jack. Thank you, sir. You are absolutely right. So the marginal cost at 1 is 4. The true value at 1 is 2. So this is our approximate change if we increase by 1 unit of production with our current level at 1. So our estimated output, estimated cost at 2 units is the original cost plus the marginal cost. And that's going to be 2 plus 4 is 6. So this is our estimate. The truth is actually 9, so we're off quite a bit. But again, you're going to see it's actually a little bit better if we have some real cost functions. So let's actually get a good one out here. And let's go through this step by step. All right, so here's a better cost function, better example. So you've got somebody working for the company and they've produced a cost function, or you're doing some kind of economic study and the cost of producing X units of something is given by this function here. they mostly look like this. So this equals cost of producing X units of whatever. Could you take the derivative, please? So find C prime. And that's question 1. Find the marginal cost function. And you see marginal, and you know you got to take a derivative. Let's say MC at X, C prime at X. And it's not too bad. All the functions are going to be pretty chill for the most part from here on out. And then once you get that, could you please find the marginal cost at 100 units? Might need your calculator. It's not too bad. Luis has got hers out already. Awesome. You might be able to do it in your head. Numbers are kind of nice. Mace, what'd you get for that?
The derivative.
Yes, sir.
0.002x plus 15.
Beautiful. And I like how you put that X in front. Does this all look good to everybody? The 5,000 goes to 0. The 15x goes to 15. The 2 comes out front, gives you the 0.02. And then the 2 goes to a 1. Does that all look good? Cool with that. Awesome. All right. So the marginal cost at 100 is 0.02 times 100 plus 15, and that's a cake thing to do because you just got to move the decimal places 2 to the right. So this is 2 plus 15, that is 17. And what I want you to think, anytime you're doing this, what does this mean? So this is the cost of producing one more item when current production is 100 units. So this will change. This function depends on X. So this marginal cost is going to change.
Based on what the original.
Yes, sir.
is.
Yeah, exactly. And just given that there's still a variable in here, depending on what the current level of production is, this output here will change as well. But it's certainly, you're right, it will change depending on that guy up there, the original cost or profit or revenue function we have. When current production is X equals 100. So, any questions on that? Is that all good? Just taking a derivative, plugging in a number. Nothing bad, calling it marginal. Same stuff we've been doing for like months. All right, so now, estimate. Yes, sir.
Chance, could we turn off the backlights? I feel like I'm gonna have a seizure with this.
Oh yeah, that's kind of shitty. Can you fix it, please, sir? I see what you mean. I'm a little too focused on this to like get it. Is that okay with everybody? Okay, it's better. Okay, yeah, that's good. Not digging the stroboscopic.
No, that's
effect.
too early for
Yeah,
that.
fair enough. That is nice. So estimate the cost of producing 101 units. So what we're going to do when we have this kind of thing is we need that marginal cost. This is going to equal the cost at 100 plus the marginal cost at 100. And this is going to be an estimate, but can we crank that out, please? We've got most of the stuff done here. We just need to get the cost at 100. So that's going to take a little bit of work, but not too bad. Let me get this cleaned up. And could somebody open up Desmos and plot that cost function for me really quick too, please? That would be really outstanding and helpful. I have a picture of it up here. Awesome. maybe zoom out is probably because of that 5,000. I think you're good with that. That should, there we go. Whoa, it's really negative. When does it become, oh, we're gonna have to scoot way over because when x is 0, it hits at 5,000. So it's actually way to the right. So maybe my function wasn't too crazy. There we go. So it's just from 5,000 and it kind of rockets up. Okay, thanks, Jack. The cost function looks like this. Just a straight rocket up. Costs increase as we need to produce more things. That doesn't sound at all unreasonable. Does anybody have the cost at 100 yet?
Yeah, I think I have.
What'd you get for that, Hannah?
It was like 6,500.0002.
6,500 point, yeah, we'll just say 6,500. That sounds
It
good
was
because
the-
it sounds like a tiny little bit.
Yeah.
So the cost of producing 100 items is 6,500. So if this is 6,500 here, then this point is 100 down here. And what we're saying is, what is the cost at 101? So to do that, we find the marginal cost at 100 and just add that on to this. And it gives us, it follows this line over 1 unit and figures out how high up it's going. What is the change right here? So this is the marginal cost at 100. That tangent line, rise. And that was just 17. So this is telling us that for each additional item we want to produce, there's an additional cost of $17 at a current level of 100. So we just add that on to what we know is the cost, and then we get 6517, and we'll just say USD on that. So let's actually see what the true value is. What is the true cost of 101? And that means we got to go back to this guy and plug in 101. That I definitely cannot do in my head. Yes, sir.
So for 100, it's actually 6,600, and then
Oh, it was 6,600?
yeah.
Okay, cool. Hannah, did you check the, just get some democracy in action here, just because we got 2 disparaging answers here.
I
Disparate.
was on my computer, so I could have done it wrong.
It's all good. You got 66?
Yeah, I just did it on Desmos.
Oh, you did it on Desmos. Okay.
And then at 101, it's
Okay, hold on a second, Jack. Cool, that's cool. So we got 6,600. And I don't want to say you're wrong. Could you just check that, please?
Yeah.
And then hold on to that 101, Jack. Appreciate it. So this, you're saying this would be 6,617. Anybody else doing this computation? What'd you get, Lorelai?
I got the 66.
Oh,
You got this?
66.
Okay, cool. Okay, awesome. All right, thank you. And thanks for saying something, Jack. And thanks for everybody helping. Hannah, thank you. So it was actually 6,600. So the estimated cost of 101 units to be produced is this much. And Jack actually cranked this out for us. What did you get, sir?
6617.01.
Damn. Pretty good. So our estimate, instead of having to go through this and plugging in 101, we can just go to this very simple function, plug in 100, our current level, and then just get this estimate, which is ridiculously close to the truth. So this is very close to the truth. Yeah, actually, shockingly so. Pretty impressed. Let me ask you this. What would be, could you estimate, how might you estimate the cost of producing 99? What do you think we could do here? Think about what we did to do 101. What could we do to estimate 99 with no new work?
Just minus 17.
Yeah, subtract off the marginal cost. Because this is just 1 unit less. So for this, just subtract the marginal cost at 100. So when we do that, we're gonna have 6,600 minus 17. This is our marginal cost. This is our true cost, our cost of 100. Marginal cost at 100. And then that's gonna be 6,583. Could we please get the truth? What is the true cost of 99 units? That's an ugly one.
6583.01.
Damn, look at that. Nice. So this is working out. This is working out way better than I even hoped it would. So the true cost is this. We're pretty much within the margin of error since these are whole items we're producing. So we can use this marginal cost to move one forward or one back really easily. Now let's do a problem together. Let me give you a new one, but let me introduce a new quantity for us. So let's talk about the average cost. The average cost of producing X items is the cost of producing them divided by the number of items. That's all. Does this make sense? Just the cost of producing the items divided by the number of items. Let me put that up. Cost of production of X things divided by the number of things. How would I take the derivative of that? How would I find the marginal average cost? Oh, well, oh man, oh, what a great week. This is starting off really good. That's beautiful. So to find the marginal average cost, I just take the derivative of this with the quotient rule. So marginal average cost, we can use the quotient rule. So how would we do that? Let's just take a look here. So marginal MAC, we'll call it MAC at X, is the derivative of the top times the bottom left alone, minus the top left alone, times the derivative of the bottom. What's the derivative of the bottom?
Nothing.
It's 1.
Ones.
Yeah. So times 1 over the bottom squared. This is the quotient rule. So we could use that formula. Notice that this is the marginal cost times the number of items. So this is X times the marginal cost, C prime, at X, minus the cost of producing X, and that's all over X squared. Now I want to point something out that I'm going to make more about on Wednesday. When is this thing equal to 0? So notice that the marginal average cost equals 0 when the top is equal to 0. That's how you get a 0 out of a fraction, when the top is 0. So when X times the marginal cost minus the cost is 0. Now watch what I'm going to do here. So this is where we have a horizontal tangent line. This is where where average cost has a horizontal tangent, has its slope of 0. Solve this just a little bit. So I'm going to add C of X to each side. So marginal cost times X equals cost at X. Now divide both sides by X and look what I've got. What's this quantity on the right? Maybe look toward the top of the board.
It's the original.
It's the original, it's the average cost. So this says that marginal cost of X is equal to the average cost at X.
it's going to turn out that when this is true, and I'll explain this on Wednesday, when this is true, we have minimized the average cost. So when this is true, and it's like I said, I'll get into the details on Wednesday, but it's just from that derivative that we took. When this is true, average cost is minimized. So let's kind of take that as just a result today. That if I want to figure out what production level minimizes the average cost, I set the average cost function equal to the marginal cost, and I figure out what x does that. And that'll tell me the optimal level to minimize my average cost. So let's take a function now. Let me give you one here. On Wednesday, we're going to talk about minimizing and maximizing things like profit and cost and revenue. We can use this result today. So let's suppose our cost function is 30,000 plus 200x plus 0.1 x squared. Would you please find the following? Find the cost at 100, the average cost at 100, the marginal cost at 100, and then estimate the cost of producing 101 using the marginal cost. And then 3, you've got a bunch of stuff for you to do here. Find the true cost of producing 101 things and compare to 2. And then number 4 is find the level of production that minimizes average cost. And you're going to use that. That'll be the mathiest thing you do this morning. Give those a shot. Work on that. I gotta go pee really bad. I'll be right back.
That's big. Anybody got a number on that one?
I got 51,000.
51,000, that's not too bad. Is that, yes, seeing some nods. 51,000, we'll just say dollars for producing 100 units. What's the average cost? This is pretty easy once we have the cost. Lorelai, what's the average cost here?
I got 510.
Beautiful, how'd you get that, friend? That's perfect.
I plugged that into the equation that we had, the C of X over X.
Yeah, love
So I
it.
took the C of 100, the 51,000 over 100, and then got 510.
Thank you, beautiful. So the average cost is $510 per unit to produce. Awesome, beautiful. Once you got the first one, you just divide by 100, so not too bad. Marginal cost. So we're gonna actually need to do two things here. First, we need to take the derivative and find that derivative function. Louisa, did you get that derivative yet?
0.2x plus 200.
0.2x plus 200. That's beautiful, thank you. That looks awesome. We looking okay, feeling okay about marginal cost. So first we take the derivative, then we plug in 100. And that's gonna be, I'll do this one. 0.2 plus times 100 plus 200. So that's 20 plus 200, that is $220. So if we wanna produce an extra unit, it's going to cost roughly $220, which is pretty good given that the cost so far has been $510 per unit. So just to produce one more is almost like half as much. So let's see what else we have here. Estimate C of 101. So what is the cost of 101? Remember how this goes. It's the cost at 100, so you kind of go back, plus the marginal cost of 100. We've got both those things right in front of us. We're just gonna take that 51,000 plus the marginal cost at 100, which was 220. And so we estimate that to be $5,120. And then let's find the true cost. Oh, yeah, that's what we do. Let's find the true cost. Anybody got that one? What is the true cost? So this is estimate. This is the truth. This one's actually way harder because you gotta go through and square all the shit. Anybody got that? True cost for me? Not yet? Cool, I'll wait. I don't have a calculator on me. I'd have to move and stuff.
I got 51,220.1.
Oh my God, 220.1, nice. Outstanding. So that's pretty damn good. Again, once again, just incredible. You doing all right, Mace? You keeping it together, brother? All right, I know, I see it. Yeah, I appreciate you staying awake. Appreciate you all staying awake. And you only have to do it 3 more days after today, so good freaking work. All right, then the level of production that minimizes the average cost. So this one's a little trickier because for this one, I'll do this one with you. So we're gonna set the average cost at X equal to the marginal cost and solve for X. So my average cost is this ghastly shit, right? Where's my cost? There it is. There's my cost function. I'm gonna divide that by X. So the average cost is that cost function over X. So that's gonna be 30,000 plus 200X plus 0.1x squared over X. Let's simplify that just a little. I would definitely recommend that. So that's gonna be 30,000 over X plus 200. See how nice that'll be? You can break this apart. You got a sum on top.
And then x's cancel in these last two. So that's sweetness. And I'm gonna set this equal to my marginal cost function right here. Notice how some nice things are going to happen. Life is gonna get good here. So we're gonna set this thing 0.2 x plus 200 equal to this critter right here. 30,000 x plus 200 plus 0.1 x. All right, do you see what I'm doing where I'm grabbing stuff? Grabbing my marginal cost formula and I'm setting it equal to my average cost formula, which is just this divided by x. Now I gotta solve. Any good stuff happen here? What good stuff's happened?
The 200 skin.
200, yeah, right? This is all rigged up to work out nice. I got this from a textbook, so it's gonna definitely work out sweet. Anything else you see, Jack? Oh, what'd you see?
The X's.
Yeah, these two combined, right? So I'm gonna actually subtract that 0.1 from both sides, and 0.2 minus 0.1 is 0.1 on the left equals this guy. Now I'm gonna solve for x. Any ideas on how to solve for x? This is pretty exciting because this worked out so nice. Help me out. What could you do? Probably no wrong answers, lots of different routes. Totally happy to sit in awkward silence. What are we thinking here? What do you wish wasn't in the problem? The fraction? How do you get rid of a fraction?
Multiply by the denominator.
Yeah, cross multiply by x on both sides. So I'm just gonna multiply both sides by x. Look, it's already better. And I'm gonna divide both sides by 0.1. That's the same thing as multiplying by 10 on this side. And then I'm gonna take square root. So I need a friend here to take the square root of 300,000 for me. Any friend will do.
Says 547.72-ish.
Outstanding, thank you. So we'll say 548. We'll round that up to 548. So to keep average cost at a minimum, we need to produce 548 items. That's the optimal if we want to minimize our average cost. So let's just write that up and then we're done with this problem. You've got 6 problems that are pretty similar to this. I don't even know if this is in there. It might be. I think it's the last problem. But let's just write up the average cost of production is minimized when x is 548 units. We could find the cost of that, but let's not. Getting a real low energy vibe in here today. So maybe we should just work on some shit. Let's take the last 22 minutes and check out web work, applied applications, whatever it's called. Is that open? Yeah, awesome. So I think it's
kind of this, a lot of this, I think everything we've talked about today is on there. If there's any stuff about marginal profit, that's just the derivative of profit. Revenue is the derivative of revenue. I think I left a few things that I'm hoping you'll ask. Just remember, just the first 6. The last 2, we're gonna have to talk a bit. I'm gonna try to have our final ready for next Monday, so we can start then. And if you also want to talk about any of the other problem sets, happy to do that too.